So the multiplier process, or the multiplier effect, is something which we come across quite a lot in economics. So we're going to look at it here in a theoretical way, and then we're going to look at it with numbers and look at a formula for the multiplier and where that formula comes from. So some of these pictures I've just taken from the Tutor to You page. So it says here, the government injects 2 million in a project to build thousands of affordable new houses. So what happens is that money becomes income to the house builders, and other businesses are going to benefit from that money. So it's suggesting building supply industries, architects. So those people are going to have increased income. So those people are going to spend perhaps in their local economy, and that becomes increased income for other people, and so on. So what happens is the increased injection from government spending is going to lead to increased income, not just for the builders, but people further down the line as well. It's here in the grey, it says, will the extra income stay inside the circular flow of income and spending? Well, some of it will, but not all of it. And that's something that we'll look at later. So this slide here will become a little bit clearer. Certainly the last part here will become clearer when we get to the end. Okay, so this here is probably the best key term for your multiplier. We don't normally say positive multiplier and negative multiplier. We just talk about the multiplier effect. Sometimes we might talk about the negative multiplier, but if we're just talking about the multiplier, it does mean the positive multiplier effect. So we could perhaps put that in brackets. We don't need to put positive there. So I've just drawn on the right hand side at the bottom the circular flow of income diagram, just to remind you of what it looks like. So what it's saying in the multiplier definition, it says when an increase in an injection, so if one of these injections goes up, so one of these injections, if one of those injections goes up, that is going to lead to an increase in national income. But it's if these injections go up by, say, for example, £10, the final increase in national income is going to be greater than £10. So maybe the final increase in national income might be £50. So we have an injection of 10 that leads to a final national income increase of, let's say, £50. If that's what happens, then in that case, the value of the multiplier is going to be 5, because we've multiplied our initial injection by 5 to get our final increase in national income. We're going to look at that in a little bit more detail on the next page. It says it leads to a greater final increase in real GDP. The negative multiplier, you see that occasionally but not very often. What that's suggesting is if injections go down, maybe by £10, then national income is going to go down by more than £10. Right? So it might go down by £50 if the value of the multiplier was 5. So let's look in a little bit more detail at what's going on and why. So I've just set this up already. So we're going to start off with a closed economy. So we often make things fairly simple and put in assumptions in place just to try and understand what's going on, and then we remove some of those assumptions. So what we've got is a closed economy. That means there's no government, so no government spending and no taxation, and there's no international trade, so no exports, no imports. So what we've got here is a situation where we've got our income, we've got consumption, and whatever isn't consumed is going to be saved. So in this example, we've got investment of £1,000. So let's suppose a firm spends £1,000. I know £1,000 won't go very far for investment. That could be 1,000 million, might be a bit more realistic. But let's suppose investment is £1,000. That £1,000 investment that the firm does becomes income for, well, let's suppose they're buying computers. That becomes income for the computer firm. I don't know, PC World, for example. So PC World has an extra £1,000 increased in income. Now we've made an assumption that marginal propensity to consume is 4/5. And we've assumed that it's the same for everybody. That's not always going to be the case, but we've got to keep it fairly simple. So we're assuming marginal propensity to consume is 4/5. So that extra income that they get, that PC World gets of £1,000, 4/5 of that is going to be spent. So So that means that consumption is going to increase by 800. And obviously with income being consumption plus saving, saving is going to increase by 200. So if consumption increases by 800, maybe that's PC World spending £800 on increasing the pay of their workers. So what that does is that increases pay of their workers by 800. So that increases income by 800. That kind of moves down there. So the same thing happens again in that of that 800, 640 is spent. So maybe their workers are going to spend that in restaurants and at the cinema, and 160 is saved. Then we go on to stage 3. So they're spending that money, they're spending their extra income at the cinema, at restaurants. So that's increased income of 640 to the restaurants and the cinemas. Of that, 512, that's 4/5, is going to be consumed, and 128 is going to be saved. We can keep going on forever, right? And what's going to happen is that income is going to get gradually lower and it's going to tend towards zero. The same with consumption and saving. So what I will do next, rather than asking anybody to work that out until we get to zero, I'll tell you what the answer is, and then we'll work backwards to get to the value of the multiplier. So if you were to do this mathematically as a sequence, what you would find is that the sum of all the terms in the sequence is 5,000. So we go 1,000, 800, 640, and then be 512, 400 and something, etc. So if we were to add all of those together, our national income has increased by 5,000. So we've got an increase in investment of 1,000, national income has increased by 5,000. Just fill these in as well, because that would be 4/5. So 4,000 increase in consumption, 1,000 increase in saving. So if national income increases by 5,000 when there has been an investment of 1,000, that means that the value of the multiplier is 5. We are multiplying the investment by 5 to get to the final increase in national income. The value of the multiplier, we call the multiplier K, which is a bit strange. So K is equal to 5. So now what we need to do is to figure out how do we get that 5. So the way that you get the 5, now if you're mathematical, you'll probably know the formula for the sequence. If not, then it doesn't matter. The formula for finding the value of the multiplier is K equals 1 over 1 minus marginal propensity to consume. So if you were to put the numbers from over here into that formula, we'd get K equals 1 over 1 minus 4/5. So I'm running out of space here. So that means K equals 1 over 1/5. So K is equal to 1 times by 5 over 1. So K is equal to 5, which is what we said it was. So in this situation, the value of the multiplier is 5. So any investment is multiplied by 5 to find out what our final increase in national income is. This is how we'd work it out in a closed economy with no government and with no international trade. So what we've got with this closed economy is the only leakage from the circular flow is saving. But in reality, if we were to have an open economy, we would have taxation and imports as a leakage. So we're just going to go on to the next page. Right, so in open economy, we've got government and we've got foreign international trade. So we've got government, we've got taxation, we've got imports, and we've got exports in an open economy. So just want to recap very quickly. There is a slideshow on marginal propensity to consume, etc. But marginal propensity to consume plus marginal propensity to save is equal to 1. So that means that marginal propensity to save is equal to 1 minus marginal propensity to consume. The multiplier formula from the previous page is K equals 1 minus marginal propensity to consume. So what you can see is 1 minus marginal propensity to consume is equal to marginal propensity to save. So what you could do is you could say K equals 1 over marginal propensity to save. However, in an open economy, saving isn't the only withdrawal. We also have other withdrawals of taxation and imports. So when we have an open economy, the value of our multiplier is going to be 1 over MPS plus MPT, which is marginal propensity of taxation, so that's the proportion of income that's taxed, plus MPM. So that's going to be the value of the multiplier that you would use for an open economy. And generally speaking, we will always talk about an open economy. We just did the closed economy as an introduction. We sometimes write that as K equals 1 over MPW, where MPW is marginal propensity to withdraw. So remember those 3 withdrawals. So the value of the multiplier you will now use as one of these 2. It depends what figures you've been given. If you've been told in a question marginal propensity to withdraw is 0.7, then that's what you'll use. If you've been told these 3 numbers, then that's what you'll use. If you've been told marginal propensity to consume, then you'll use that formula. So all of the formulas are doing the same thing, but it just depends what information you've been given. We'll look at changes in the value of the multiplier in another slideshow.